without further ado, let's get started. So number 1 says express each of the following numbers in scientific notation with 3 significant figures. Okay, so at this point, I hope you guys know what significant figures are. If you don't, we'll do a quick little recap and we'll take a look at the rules right now. So rule number 1, which I'll write underneath, is any non-digit 0 is significant, right? So anything that doesn't have a 0, so it's or any number that's not a 0 is significant. So 1, 2, 3. So in 123, this number, all 3 digits are significant. That's what I'm trying to say. So number 2, leading zeros are not significant. So what I mean by leading zeros, let's say we have a number like this, a very small number, a decimal number. These 3 zeros are not counted as significant digits, but they are counted as placeholders. So don't get confused between significant digits and placeholders. So there's only 2 significant figures here based off rule 1, right? The 2 and the 1, okay? So rule number 3, sandwich zeros are significant. Okay, so I'm gonna erase rule 1 and 2, so I could give me some space. Okay, so sandwich zeros, what I mean by this rule is, let's say we had a number like 1000, let's say 25. So this 0 is sandwiched in between 2 non-digit zeros, right? Sorry, or 2 non-zeros, this 1 here and this 2 here. So that makes this 0 significant. So that means here I have 4 total sig figs because these zeros are sandwiched. Okay? Then the 4th rule and the last one is zeros after the decimal are significant. So for example, if I had a number like 1.000, I would have 4 significant digits here, and all these are significant because these zeros are after the decimal. So those are the basic rules of significant digits. I hope you guys got a quick little recap, but hopefully by Chem 101 you guys are familiar with their sig fig rules. So let's just move on and start solving the questions. Okay. So number 1 says to express each of the following numbers in scientific notation with 3 significant figures. Okay. So the way I approach these problems is I'm looking at the first one, part A, and I know that I have to report 3 significant digits, and this number is 2,900,000. And the only way I could do this with 3 significant digits is by putting it in scientific notation. So I have to put it in scientific notation first. So the first thing I'm going to write down are the 3 significant digits, which is 2.90, right? And these are all significant digits because of the following rules I mentioned before. If you guys don't see that, please look back at the rules, but it'll make sense. So then we do the times 10 to the power of something, right? And we need that exponent. So the way we get that exponent is we count from this digit, the 2, after that, and we're just going to count the spaces after that comma or after that 2. So it's 1, 2, 3, 4, 5, 6. So that means our exponent is to the 6th power. So your final answer should be 2.90 times 10 to the 6th. And that's by counting the spaces from the first significant digit all the way to the end of that number. Okay? So that's number 1. Or part A. So part B, we have a very small number, which is 0.005865. And again, the first thing we have to do is probably turn this into scientific notation because it's going to look so much cleaner. So the first thing I'm going to do is I'm going to write the first 3 sig figs down. So 5.86 but this 6 is next to a 5, so that means if the number next to the last significant digit is greater than 4, I have to round that. So it's not going to be a 6, but it's going to end up being a 7. So it's 5.87 times 10. And again, for numbers smaller than 0, I'm going to start, for numbers smaller than 1, I'm going to start at the decimal point and go over to the first significant digit. So it's 1, 2, and 3. So I'm going to stop right where I put the decimal point, which is going to be to the negative third power. And the reason why it's negative is because our number is greater than 1, smaller than 1. So every time your number is smaller than 1, the exponent in scientific notation is negative, and every time the number is greater than 1, our exponent is to a positive power, as you saw in part A. Okay. So part C is this very, very small number. So obviously, again, scientific notation seems like the best way here. So the first thing I'm going to do is I'm going to write down my first 3 significant digits, which is 4.56, and then times 10 to the, then I got to find my exponent. And I already know it's going to be negative because my number is less than 1. So again, I'm going to start from my decimal point and count the spaces over. 1, 2, 3, 4, 5, and 6. Okay, so it's going to be times 10 to the negative 6. So there's our answer for part C. Now part D, we have this number, 410,870, and our objective again is to turn it into scientific notation because we want 3 sig figs. So I'm just going to put in scientific notation and say it's 4.11, round this one off just in case you guys don't see that, times 10 to the 1, 2, 3, 4, 5. So times 10 to the 5th. Okay, and that's our answer for part D. So hopefully number 1 was pretty straightforward and just review for most of you guys at this point. If not, I encourage you guys to practice more on these problems. Okay, so moving on to number 2. Number 2 says perform the following operations with the correct number of significant digits. So here we have a mixed operation of subtraction and division. Now, for these questions, the first thing you have to do is remember the rules of sig figs for operations, for mathematical operations. So if you guys remember in Chem 65, when we're multiplying, so let's say 7.56, for example, times 1.0, our final answer for multiplying or dividing should have the least significant digits as possible depending on our numbers. So in this case, we have 2 significant digits and 3 here. So our final answer should be reported as having 2 sig figs because that's just how the rule says. So in this case, instead of having 7.56, our answer is actually 7.6 because this gets turned into the same number because it's multiplied by 1, but we have to take into consideration the significant digits in each one. So that means my final answer here would be 7.6. So that's just a sample calculation for multiplication or division. You always take the number with least amount of sig figs and carry that over to your final answer. Okay, so that is multiplication and division. Those rules are the same. Now for addition and subtraction, for a quick recap, let's say we had 7.56 and we're subtracting 2.5710. And let's say this is our number we're subtracting. So for these questions, we don't care about the number of sig figs. What we care about is the least precise number. So the least precise number, meaning having less decimal spaces to the right of a number. So in this case, it seems like, or it is that the 7.56 is the least precise because it's only precise to the hundredths position, which is here, right? Tens, hundredths. So that means that I have to draw some imaginary line or just a line indicating that my answer should only have a hundredths position reported. So I'm just going to go about solving this question like I normally would by subtracting. So 0, that's carried over. So 14, that's going to be 16. So I have 9, 9, and 5. So 5.99 is my answer. And notice how I don't report, actually, might be a little different. It's going to be 15 here. That's a 10, so 9. So that's my mistake. So it's going to be a 15 minus 7, which is 8. Okay, so I just did a quick little mistake. I didn't see that I had to borrow from this neighbor as well. So that means that my final answer is 5.98, but I should only report 2 digits past the decimal, yes, but I also have to look at this number after I cut it off. Is that number greater than 4? And the answer is yes. So that means that this 9 is going to round this 8 up to a 99. So that means my answer is 5.99. Okay. The arithmetic may be wrong, but the concept stays the same, is you always want the least precise answer when you're adding or subtracting. So it doesn't matter if you're adding or subtracting, we want to have the least precise answer. Okay, so those are just sample calculations for addition, subtraction, multiplication, and division. Now to solve this problem, the first thing we have to do is do the subtraction first, because the subtraction is what's going to limit our answer's precision. So again, the first thing I like to do with these is I like to set up my subtraction part separately and then worry about dividing later. So I have 14.854 minus 14.828. And the first thing I want to do is subtract those two numbers before I divide, because just in case I lose some digits towards the end. So again, just doing simple subtraction. We have so that's going to be a 4, that's going to be a 14. 14 minus 8 is 6. 4 minus 2 is 2, that's a 0, and that's a 0. Okay, so it turns out that our answer is 0.026 for this operation. So notice how we initially start with 1, 2, 3, 4, 5 significant digits in both numbers here, but we end up with only 2. So this is what I mean by doing the subtraction operation first separately, because you might end up with least sig figs later on. So now that we have this answer, we could just simply write out what our final operation will be, which is division. So we could write it down like this, and then since we're dividing, and we know that the rules for division is taking the least amount of sig figs, which clearly here is 2 because of the 0.026. We only have 2 significant digits here. So our final answer should report only 2 significant digits. And in this case, when we divide, we place in the calculator, we get 6.7 times 10 to the negative third, or 0.0067. Okay? And that is how you do part 2A. Okay? Now for part B, it's a little bit simpler because we don't have mixed operations, as we call them. We just have simply multiplication and division. So here we could just simply plug this to in the calculator, but the first thing we have to do is identify how many significant digits our answer is going to have. And in this case, it's always the least amount because we're only multiplying and dividing. So this one has 4 sig figs, so that's 4, that's 3, and that's 3. So our answer should have 3 significant digits at the end. So when we do this operation on our calculator now, we should have an answer of 4.17 times 10 to the negative 32. Okay? Now that's part B. Again, multiplication and division, we take the least amount of significant digits in our number. So part C. Part C looks about the same. We're just dealing with multiplication and division. So again, all I have to do is identify the number with the least amount of significant digits present. So this one has 2, this one has 3, and this one has 2. So the least amount happens to be 2. So our answer should only have 2 significant digits reported at the end. And it happens to be, once we plug this in our calculator, we get an answer of 5.3 times 10 to the negative 8. Okay. Now, this is number 1, number 2. We'll continue with number 3 on the next video. Thank you very much.